This is a solution to number 5 on the 2012 exam. So here we have this equation where they tell us that B of t is the weight of the bird in grams and t is time in days. B of t is the solution to our differential equation, and we've got this initial condition which I'm sure we will use at some point. So part A is the bird gaining weight faster when it weighs 40 grams or when it weighs 70 grams. Alright, so let's work on that. For part A, we want to know about the rate when B is 40, so that would be 1/5 of 100 minus 40, which is 60, which gives us 12. And then when B is 70, we've got 1/5 of 100 minus 70. 100 minus 70 is 30, which gives us 6. So now we can say, therefore, the bird is gaining weight faster when it weighs 40 grams. All right, part B, we are looking for the second derivative in terms of B. So dB dt is 1/5 100 and we want the second derivative. So this would be 1/5, and in the parentheses we know that the derivative of 100 is 0, and the derivative of negative b will be -1. dB dt, which gives us -1/5 dB dt. Now we know what dB dt is equal to, so let's substitute that in. And we get -1 over 25 times 100 minus b. So now for the second part of the question, they're saying to use our second derivative to explain why the graph of b cannot represent or cannot resemble the following graph. So remember, the second derivative tells us about concavity, and that on the interval from 0, or actually from 20, all the way up to 100, the second derivative is negative. Therefore, b must be concave down. But if we look at our graph, notice there are parts that are concave up. So we can say part of the graph shown is concave up, and therefore is definitely not our function b. All right, last part, my favorite part, we're going to use separation of variables to find y. So dB dt is 1/5 100 minus b. So let's go ahead and separate variables. So we've got dB and now I've got 1 over 100 minus b. which means that we can integrate both sides. Now the right side will get 1/5 t plus c. The left side is going to be an ln. And if you don't see that the integral of this is equal to this, you may want to do some u sub on the side and let u equal 100 minus b. So now we've got to go ahead and solve for b, or maybe before we do that we'll find c. They tell us that b of 0 is equal to 20, so let's use that information. So b of 0 is equal to 20. So on the right side we've got just c. Here we've got, let's see, negative ln of 80. And we don't need the absolute value because 80 is positive. So we'll substitute that back. So we've got 100 minus b equals 1/5 t minus ln of 80. Okay, so now let's move that negative. 100 minus b. So we've got negative 1/5 t plus ln of 80. And we can exponentiate both sides. So we've got e to the negative 1/5 t, and this will be times e to the ln of 80. And what that does for us is allows us to simplify this. This is really just 80. So now we've got minus b is equal to, I forgot already, let's see, e to the negative 1/5 t times 80. Actually, maybe we'll just make that t over 5. And now we have to decide about our absolute value. Will this be this function, or this is a b over here, or will it be equal to the negative? And we know that when we plug in 0 that we have to get 20. And that's not going to happen with this. So this is the equation we're working with. So let's solve for b. We're going to say that b is now equal to 100 minus 80 e to the negative t over 5.